Hi, good morning. Today we're going to continue with implicit differentiation. Today we're going to focus on either dy dx equals 0 or dy dx undefined. Question number 1 is a review question. Let's try to refresh our memory before we go into something a little bit more difficult. Let's take a look at number 1. So you have to find all the points where the tangent line is horizontal. So the tangent line is horizontal means when the m equal to 0, because horizontal line have a slope equal to 0. So we have to find the dy dx and then make it equal to 0, and then from there we solve for the x and y. Now we have a y equal to a fraction. Because the denominator is a number 2, so it's not practical to use the quotient rule. So I decided to rewrite into 2 fractions. And then we know that you can make the half in the front just to make it easier for the derivative. So from here, I'm going to find the derivative y prime or dy dx. 1/2 stay the same. So derivative e to the x times 1. So 1/2 stay the same. E to the negative x, and then u is negative x, so therefore u prime is negative 1. So we get y prime equal to 1/2 e to the x minus 1/2 e to the negative x. So we found the derivative. So we need to make the slope equal to 0. So we're going to make 1/2 e to the x minus 1/2 e to the negative x equal to 0. So from here, there are more than one way to solve the problem. So it's up to you how to solve it. I decide to multiply each side by 2. So I'm going to times 2. So now 2 times this. So we get e to the x minus e to the negative x equal to 0. So some people, when they start this, they already know the answer. If you already see the answer, then you can write down the answer. If you want to continue to solve more, then you continue. So we are going to add this to the other side. Same base, so the exponent had to be the same. So x equal to negative x. And then you plus x both sides. So you got 2x equal to 0. Then x equal to 0. So we found the x value. So now we have to find y. To find y, you always go back to the original function to find y. So we have y equal to the fraction. And then we're going to substitute the x by 0. So e to the 0 is 1. E to the negative 0 is also 1. That's basically the same as e to the 0. So now we got 2 over 2, which is 1. So therefore the point is 0, 1. So we found the point that has horizontal tangent, which is 0, 1. Now let's go to question number 2. Question number 2. This is going to be the graph of this function y4 plus y squared equal to x times x minus 1. These two are horizontal parabola. So the graph is given to us. Part A, find dy dx. So you have to find the derivative using implicit differentiation. B, explain why the function has no horizontal tangent. So we are going to explain it after we found dy dx. No horizontal tangent, it means there's no way you can draw a line that is have a slope equal to 0. C, find all the points on which the tangent line is vertical. So that means you have to find where the slope is undefined. So let's take a look at part A first. Part A. So we have the y4 plus y squared equal to x minus 1. I have to find the derivative. So I decided to multiply this out first, make it easier because I don't want to use the product rule. So y to 4 plus y squared equal to x squared minus 1x. So now I'm going to do the implicit differentiation. So we learned it before and we refresh our memory yesterday. So 4y cubed times y prime. Don't forget the times y prime. 2 y to first power and times y prime. And this regular 2x minus 1. So now I'm going to factor out the y prime. And then I divide this both sides. So I found my dy dx, which is 2x minus 1 over 4y cubed plus 2y. Now let's go to part B. Explain why the function has no horizontal tangent. So, no horizontal tangent. So that means there's no way m equal to 0. So if you want to prove there's no way the m equal to 0, you have to assume m equal to 0 and then see what happened. So we use the technique that we learned in geometry. So you assume it happened first and we contradict, then you say there's no way. So now we had the dy dx equal to 2x minus 1 over 4y cubed plus 2y from part A. So it makes it equal to 0. If a fraction equals 0 only happens when the numerator equals 0. So 2x minus 1 equals 0. Plus 1 both sides. So 2x equals 1. Then x equal to half. So that means the location will be at the half comma something. Now from here, there are two ways to do it. So let's take a look at the graph. Method number 1. The graph is given. We look at the graph. So let's take a look at the graph. X equal to half. This is 1, 2, 0. From 0 to 1, there's nothing over here. That means half comma y does not exist. So if there's no point over there, then definitely you cannot draw a horizontal tangent. So we look at the graph. There is no points with x equal to half on the graph. The point does not even exist. Then you cannot draw a line. So we cannot draw any tangent line on half comma y. So horizontal tangent does not exist. In other words, there's no horizontal tangent. So some people said, what happens if the graph is not given? How do you do it algebraically? So definitely we can do it algebraically if the graph is not given. So we go back to part B. We have dy dx equal to 2x minus 1. You get 4y cubed plus 2y equals 0. So we say 2x minus 1 equals 0. And 2x equals 1 and x equal to half. We had half comma what? You need to find y. So if the graph is not given, so then you had to use original function and find y. If you can find y, then that means you can draw it If you cannot find such point, I mean there's no y value, then there's no horizontal tangent. So we had to go back to the original equation. So we know that x equal to half, so we don't going to solve for y. We substitute, and then maybe you already noticed something is very special over here. We learned that before. Y to the even exponent, a number to even exponent, is either positive or 0. So same thing for y squared. So y to the 4th power is positive or 0. Y squared is positive or 0. So that means y to 4 plus y squared is no way to equal to negative 1/4. So we had no solution. So no point on the curve with x equal to half. There's no such point. So therefore the conclusion. So we say that the function has no horizontal tangent. So we finish part B with 2 different methods. Let's take a look at part C. For part C, find all the points at which the tangent line is vertical. So dy dx equal to undefined. So from part A, we found dy dx equal to 2x minus 1 over 4y cubed plus 2y. So we want to make it undefined, so therefore 4y cubed plus 2y equal to 0. So it looked like we can factor. So they have a 2 in common and y in common. So we factor 2y. So you get 2y squared plus 1 equal to 0. 2y equals 0. Or 2y squared plus 1 equal to 0. So now we solve it. We get y equals 0. 2y squared equal negative 1. And y squared equal to negative half. Y squared equal negative half is not possible. A number squared either positive or 0. So here we have no solution. So there's only one part. So when y equals 0, we have to find x. So how do we find x? We have to go back to the original function. So the original function is y to 4 plus y squared equal to x minus 1. So you get 0 to 4 power 0, 0 squared 0. And then we found this x equals 0 or x equal to 1. So now we get 2 points. Okay, 0, 0, 1, 0. So there are 2 points at which the tangent line is vertical. So we found 2 points using the algebraic method. So what happened? The graph is given. Some people are thinking about it. If in part B you use a graph, how come part C you're not using the graph? We can look at the graph also. So now let's take a look at the graph. So this is horizontal parabola, another horizontal parabola. So we say the horizontal parabola is very special. This is one. Okay. So at this point over here, at this point, you're going to have m equal to undefined, just like the circle, and same thing over here. So this part is undefined. So based on the graph, we can see that at 0, 0, at the 1, 0. Okay, so at 0, 0 and 1, 0. At 0, 0 and 1, 0, the curve have vertical tangent. We get the same answer. So we finish question number 2. Now let's take a look at question number 3. Question number 3. We got x squared plus xy plus y squared equal 27. Find a point on the curve of a given function where the tangent line are vertical. So for number 3, so same idea, we got dy dx equal to undefined. So we need to find the derivative first. So here we're going to use a product rule. So now we got 2x and plus 1y plus xy prime. And the derivative of this will be 2y times y prime. The derivative of a number is 0. So I might 2x minus y both sides. So I got xy prime plus 2y prime equal to negative 2x minus y. Factor out the y prime. So now we got y prime equal to negative 2x minus y over x plus 2y. So I found the derivative. So after we got the derivative, we had to make it undefined. So that means x plus 2y equal to 0 minus x. So here, something happened. You don't get a number, you get an equation. Y equal to negative x minus 2. Then, what do we do? So we're going to use two equations to solve for x, y. So a system equation. So the two equations that will be the one that we just have and the one that is given. So to solve the system equation, the best way is to do substitution. So we're going to substitute this into this one. So we're going to have x squared plus x minus dy per parenthesis. And then from here, we can solve for x. So this is 1. 1 minus a half is a half. And then 1/2 can turn into 2/4. And then we combine, you get 3/4. Now we can multiply both sides by 4 over 3. So this cancel, you get x squared. This is a 1, this is 9, you get 36. So we know that x equal to plus minus 6. Now we're going to find y. Now we're going to find y. So when x equal to 6, so how do we find the y value? To pick one of the equation, definitely pick this one. So we get y equal to negative x over 2, negative 6 over 2, that's negative 3. So we got the first point, 6 comma negative 3. So when x equal negative 6, y equal to negative x over 2, so negative 6 over 2. There'll be 6 over 2, which is 3. So we got the second point. So we found both points, 6 comma negative 3 and negative 6 comma 3. So we finished question number 3. Okay, let's take a look at number 4. Okay, number 4. Number 4, we put everything together. So okay, it looked like that I had to use another video. So you click on video number 2 to see how I solve number 4.